All right, so now that we have answered parts A and B, let's continue with part C. So here it says let the area of the triangle XYZ be A. And it's another show question, so we need to show that A squared equals 9x squared times sine x squared z. So let's start. It's an area of a triangle. So we think, well, what do we know about area of a triangle? We know it's a half AB sine C. So if I start with that, a half times A and B, in this case, will be 6 and x, because those two sides form angle Z, which we need. We can see from up here we need sine Z, so that's the angle that we're going to use. So we have that. And we just need to simplify that a little bit. So half of 6 is 3, so we've got 3x sine Z. Now that's what the area is equal to. And of course here we see that it's a squared, so we need to square everything. So when you square everything, make sure you square every term in there. So square the 3, square the x, and we square the sine. And you can write it as sine z in brackets all squared, or you can write sine squared z. It's the same thing. All right, so that was straightforward enough. Now going to part D, again we have a hence, and so that implies that we have to use part C. So if I just again write down what a squared was equal to, a squared was equal to 9x squared sine squared z. Now, we're needing to show this. The thing I would notice straight away is that there's no sine z in there. And the actual trick, there's actually a trick to this one that you haven't actually learnt this skill yet, but it's coming up in the second part of the trig unit. A little rule that is very handy here that you haven't used is sine squared x plus cos squared x is equal to 1. Now, we'll get to why that is in the second part of the trig unit. Now, I want it to be in terms of z, and what I'm going to do is I want an expression for sine z squared. So I'm going to replace the x's with z. And so I'm going to replace that, take the cos over the other side. So 1 minus cos squared z. So I get that. Then from there, what I can do is replace that. Because what we have from up above in part B, so the other thing we have in part B, we found that cos z equals 5x minus 16 all over 3x. So this is what made me realize that maybe I needed to replace the z squared, the sine squared here, is the fact that it's disappeared. And if I use this rule, I can get something with cos squared in it, and I have an expression with cos squared. So I had to make a lot of connections there, which makes that quite tricky. So then, doing a lot of substituting, we have a squared equals 9x squared times, and we're going to replace the sine squared z with this first of all. So it's 1 minus, now I'm not going to write cos squared, I'm going to replace this, the 5x minus 16 over 3x. So I'll put another bracket, 5x minus 16 all over 3x squared. Okay, all I did there, replace that with that, and squared it, of course. Now it's a matter of, because it's a show question, it's a matter of just playing with the algebra. If I expand the very big brackets, the outer brackets, I'm going to get 9x squared minus. Now here, I'm going to have 9x squared. On the top, I might just leave that for a second. So I'll have 5x minus 16 all squared over, now remember, when you have a fraction inside and you're squaring it, you need to square the numerator and the denominator. So 3x squared is the same as 9x squared. So that worked out quite nicely. It got rid of that fraction. So now I can just cancel that out. I just got 9x squared over 9x. So that disappears. And then it's just a matter of expanding, collecting like terms. So 9x squared minus, I'll keep it in brackets because it's minus all of that. So expanding this part, I get 25x squared minus 160x plus 256. And I can already see I'm getting numbers that look correct according to what I'm trying to show. And then just expanding this out. Remember, it's minus everything that's inside the brackets, so each sign will change. So 9x squared minus 25x squared. So I get minus 16x squared. And then minus 160x, but I've got a minus at the front, so that becomes plus 160x. And then I have minus, the minus at the front, but I have a positive inside, so it makes it minus. And that's what we were trying to show. Okay. And the very last one requires us to make, again, a lot of connections. Part 1 says, hence write down the maximum area for triangle XYZ. Now, if you notice in part A there had that y was equal to minus 16x squared plus 160x minus 256. And then we just got an expression for a squared. A squared equals exactly the same thing. Minus 16x squared plus 160x minus 256. Now in part A here, we also found from parts 1 and 2 that there was a maximum when x equals 5 and the maximum was 144. These are exactly the same. So when it's asking for the maximum area, then we know this is the same. So the maximum of this function, so of a squared, the maximum is 144. The question asks for the maximum area, so therefore the area is 12 centimeters squared, of course. Okay, that's part 1. Part 2, just as easy, because then it says what type of triangle is the triangle with the maximum area. So then all we need to do is say, all right, well, I know that the maximum area happens when x is 5. So I have a triangle, if I quickly draw it. Now, what do I have? X, Y, Z. And I already know this is 6. We know the maximum area occurs when x is 5. So this is 5. And again, go back to what you already know. You know from part B, part 1, you know that Z, because this is Z over here, you know Z is equal to 10 minus x. But now we know what x is. We have a value for x. So it's 10 minus 5. So Z equals 5. So this is actually 5, which then easily tells us that it must be an isosceles triangle. Okay, so lots of things you have to know there in this question. Very obvious here how you have to connect all the parts. This is very important in these long questions. Okay, I hope that was helpful. Bye.